when we deal with electricity, actually we deal with electric voltage, electric current, electric resistance, capacitance. We need like device or equipment that measure all these quantities. Actually, we have something called multimeter, which used to measure all these quantities. Okay, we have two kind of multimeter. We have the digital multimeter and we have the analog multimeter. Let's connect these two wires. Actually, we connect every time the black wire and the common over here. Connect it like this and this. Okay, if I want to measure voltage, resistance, capacitance, for example, the diode, all these things, I have to connect the red wire in this hole. Okay, so now, and I have this the red terminal and the a black terminal. Usually this for the positive terminal and this for the negative terminal. Okay, now voltage measurements. Okay, to turn on the DMM. Okay, now we have I choose the voltage measurements. Actually, we have AC measurement, and we press on the function over here so we can measure the DC voltage. Okay, let's try to measure the DC voltage. Okay, now we know that this battery 1.5 volt DC, and this is the positive terminal and this is the negative terminal, so we can measure the voltage. We connect the red wire on the positive and the black wire connected to the negative side. So we have on the LCD screen 1.571 volt DC volt. And if I change the direction and the position, we get minus 1.571 volt. Now let's try to measure the AC voltage. Okay, I have over here this. Okay, this is the circuit, and this is the extension. This carry a 110 volt AC volt, and because we are, for example, in the United States, the voltage is gonna be 110 AC volt. Okay, now let's start to measure the voltage, which is AC. But before we measure the voltage, we have to make sure that this here we choose the AC measurement. We can see on the LCD we get 113 volt, around here 113 volt AC volt, and this is correct. And here it doesn't matter to change the to connect the red or the black in any direction. Now resistance measurements. Okay, now I have this resistor. I will measure the resistance of this resistor. Okay, first I have to choose the resistance measurements. Okay, now I connect the wires and the terminals. So, and as we know, this digital multimeter is auto range, so I don't have to change the range, it's auto. Okay, now this around 100 kilowatt. Oh, I have here the variable resistance. This is the variable resistance, and this is the maximum resistance for this resistor or potentiometer is 10 kilo ohm. Now the diode measurement. We have this diode actually, and as we know, where's the anode and where is the cathode? Actually, this is the cathode, this side is the cathode. Why? How can we know? Okay, we can know by looking for this bar. There's a gray bar over here, so we can know that this is the cathode and this is the anode, and this is the positive side of the diode, and this is the negative side of the diode. So anode and cathode. And let me just explain it over here and draw the symbol of the diode. Now just we have to make sure that we choose this one, and there's on the LCD there's the diode symbol, and just look at this symbol in the here it's drawn, and to measure the forward voltage for the diode and make sure it works and it's not damaged, just you have to make sure that to connect the red wire to the anode and the black wire to the cathode over here like this, so we can know if it works or not. And in the same way, for example, we have this diode. Actually, we have this diode over here, and we connect it like this. So here we go. So we have over on the LCD 0.538 volt, and this is the forward voltage for the diode. This means it works 100% and we can use it and it's not damaged. And if I open it and change the wires, give me overload. And if we press function again, we will see the sound symbol over here. Okay, what does that mean? Actually, this means that we can, okay, if we connect it like this, there's like short circuit or there's connection. Okay, how can I actually use this this tool or this like feature? Actually, if I have, for example, this wire and I want to make sure it's okay, and I want to make sure that we can use it and there's no cut in this wire, I can actually use this this feature. Okay, now just connect it like this and connect this one. So this means that there's no cut and this wire I can use it and everything okay. Now the capacitance measurement. Okay, now I have this capacitor and this like actually this parallel capacitor, and we can look at this capacitor and we can know the capacitance of this capacitor, which is 10 microfarad actually over here. So I will try now to measure the capacitance of this capacitor. And just before I try to measure the capacitance, let me just draw the sample of this capacitor. Okay, now we can see over here that there's one terminal longer than the other. So this means that this terminal is the positive and the terminal is the negative. So as here, so this is the positive and this is the negative. Like this. And if I want to measure the capacitance of this capacitor, I have to make sure that to connect the red wire over on the long terminal, which is the positive, like this. But before I do that, just I have to make sure that I choose the capacitance measurement. Now I do it again. It's a little bit hard. So now, oh sorry. So we can see on the LCD that the value of the capacitor of this capacitor is 10.43 microfarad, and this is the correct. Here we can measure the frequency of any signal. For the LCD gave me 59.97 hertz, and this is correct actually. And by the way, I can use this button to press it and hold the reading, for example. So now if I take this out, it's okay. So I will hold the reading, and I can now here I can know the temperature. And here is it's in this room it's gonna be 79 Fahrenheit. Okay, now the current measurements. Actually, I have more than one choice over here or option. So this option give me like that give me the opportunity to measure the microampere. Okay, and this is very small readings and very small amps, and here the milliamps, and this the amps for big applications. So okay, so this depends on my application. Okay, now I have this simple circuit which consists of voltage source, like for example I have this 4 batteries, 1.5 each one, which give me 6 volt as a total. Okay, now the voltage is gonna be, for example, okay, 6 should be 6 volt, but I will try to measure it like using the digital multimeter. Okay, and I have this over here, this resistance. I have this resistor actually. I will measure the resistance of this resistor using the digital multimeter, and just remember that when we measure the current, I have to connect the ammeter, okay, in series with the circuit. And if I want to measure the voltage across this resistor, I have to connect the voltmeter like in parallel with this resistor. Okay, now let me try to measure the resistance of this resistor. Okay, just choose the resistance measurement, and let me see how much this resistance. It's gonna be 101.1 kilo ohm. So I will write down over here 101.1 kilo ohm. Okay, now let me try to measure the voltage over here across this voltage source, which is battery. Okay, I have to make sure that to press a function to change, it's now AC, but I need to measure DC voltage, and so I connect the red to the red, which is the positive, and the black to the black, which is negative. So I can get 6.29. So 6.29 volt. Okay. Now let me try to measure the voltage. Before that, let me try to connect the circuit. Okay. Now I'll try to measure the voltage across the this resistor. It's gonna be, if you see that, because I connect the red one on the negative side and the black wire to the positive side, so I will get on the LCD, on the digital multimeter, minus 6.28 volt. Okay, so here's the voltage, 6.28 volt, and in this case the voltage over across the resistor is gonna be the same as the source actually. Okay, now so actually this voltage called V open circuit, because when I measure this voltage, I measure the voltage when the voltage source was actually open circuit. There's no load, there was no load connected to the voltage source, so this is the V open circuit. But V and the circuit, which is like which is connected load to the source, so V is gonna be 6.28 volt actually. You see here, so only this is called V open circuit, and this is the voltage when the circuit is connected. Okay, let me try now to measure the current. So I have to connect the digital multimeter or the ammeter in series with the circuit. So in this case, just make sure that you connect this one correct. Actually, if I want to now I will change to measure, for example, in milliamps. So now here give me that I can use this hole to measure milliamps and microamps actually, so I can just keep it. Okay, now milliamps, and make sure that you choose the DC because this is DC application and there's a DC source. Okay, now just make sure that you connect this in series with the circuit. So I have this. Now just connect this one here and connect give me milliamp, like 0.05 milliamp. So this means it's less than milli. It's gonna be micro. Make sure that's DC. We can see now the current is 62.1. Let me try to hold the reading. So it's actually 62.0 microamps. So now we measure the current easily. Just make sure that to connect the digital multimeter in series with the circuit to measure the current, and in parallel across the resistor to measure the voltage. And again, if you want to measure like the current for like big applications, just take this out and connect it over here, and just remember that this is only to measure the current, no voltage, nothing like that. So just make sure, because if you use to measure, for example, voltage, this one, if you try to measure the voltage, maybe you'll damage the digital multimeter. I mean, because this like a new digital multimeter has a fuse, so you have to change the fuse